The last thing that we're going to look at in this chapter is solving rational equations. The tools that we're going to need in order to do this is we do want to be able to understand and extend the concept of LCD to include variables and expressions. We need to know how to solve linear equations, and we need to know how to solve quadratic equations. The procedure that we're going to use in order to do this is we want to find the LCD for all terms in the equation. The LCD may contain variables and/or expressions as well as numbers. We want to rewrite each term with the LCD and then cancel all denominators. Alternatively, you can multiply each term by the LCD to cancel the denominators. We want to solve the resulting equation using either linear or quadratic techniques. Check your solution. For the check your solution on this, you don't actually have to check the whole equation. You can. But what we're doing is we are looking for something specific in this case. We want to discard any solutions that create an undefined term. Remember that in order for it to be undefined, it means that the result in the denominator is equal to 0. Let's start with an example from Chapter 1. So, in Chapter 1, we looked at equations that contained fractions, and all of our denominators were numbers. So recall that what we want to start with is we want to start by identifying the LCD. The LCD for this is going to be 12. So I want to rewrite each one of these terms with a denominator of 12. The first one stays the same. The second one, in order to get a denominator of 12, I want to multiply by 2. I'm going to do the same thing to the top and the bottom. Y over 2, to get to 12, I want to multiply by 6. I'm going to do the same thing to the top and bottom. We get 6y over 12. And the last fraction we want to multiply by 3. We get minus 3 over 12. So recall that when all of our denominators are the same, we can cancel them. What we are left with is y plus 2 equals 6y minus 3, and we can finish solving. So I'm going to move all of my variables to one side. I'm going to subtract by 6y. We get negative 5y plus 2 equals negative 3. And I'm going to subtract 2 from both sides to get my constants on the other. We end up with negative 5y equals negative 5. I can divide by negative 5. And my final answer is y equals 1. We're going to take this same process and we're going to apply it to having fractions and expressions in our denominators. Okay, so example A, we have 5 over 2x equals 17 over 18 minus 1 over 3x. So for the LCD, I'm going to go ahead and start with the number part. Our LCD for the numbers is going to be 18. Now, unfortunately, this doesn't cover everything. Notice that in the denominators, we also have some x's, and so I want to include that in my LCD as well. My LCD will be 18x. All right, so now we want to go ahead and rewrite everything with an LCD of 18x. 5 over 2x, I want to multiply by 9 to the top and the bottom. We get 45 equal over 18x equals. The second term, we have the 18, we are missing an x, so I'm going to multiply by x. We get 17x over 18x. And the last one, in order to get from 3x to 18x, we want to multiply by 6. So we get 6 over 18x. All of my denominators are the same now, so I can cancel them. We are left with 45 equals 17x minus 6. This is a linear equation, so I have all of my variables on the right. I want to move all of my constants to the left. I'm going to add 6 to both sides. We get 51 equals 17x. And then I want to divide by 17. 51 divided by 17 is 3. And we have this as our solution. We do need to check this and remember that all we're looking for is, does this make any of our denominators equal to 0? So if we plug into the first term, 2 times 3, is it 0? No. 18 is okay, it's a constant. 3 times 3, is it 0? No. And so this will be our final solution. All right, let's go ahead and try another one. We have 1 over x equals 1 over 5 plus 3 over 2x. If we start with our LCD, for the numbers, it is going to be 10. And again, on this problem, I have some x's in my denominators, and so I need an x in my LCD. All right, first fraction, how do we get from x to 10x? I want to multiply by 10. So we get 10 over 10x equals. The second fraction, what do we need to multiply in order to get from 5 to 10x? We're going to multiply by 2, that gets me to the 10, and we want to multiply by x to get the x. We're going to do the same thing on top. So we get 2x over 10x. And the last fraction, in order to get from 2x to 10x, I want to multiply by 5. And I'm going to do the same thing to the top. We get 15 over 10x. Now that my denominators are all the same, I can cancel them. My new equation is going to be 10 equals 2x plus 15. This is a linear equation, so I have all of my variables on the right. I want to move all of my constants to the left. (10 minus 15 gives me -5 equals 2x, and then I can divide by 2. We get -5 halves equals x. Final step, we want to go ahead and check. And again, remember, all we're looking for is, are the denominators equal to 0? If we plug into the first fraction, negative 5 over 2, is it 0? No. 2 times negative 5 over 2, is it 0? No. And 5 just stays as 5. So this is going to be our final solution. If you're following along with the paper notes, I'm going to go a little bit out of order. I'm going to skip over to example F. Example F, we have x over x minus 3 equals 3 over x minus 3 plus 9. All right, so in order to do this problem, one of the first things we notice that's a little bit different is our denominators are now binomials, but we're still going to treat it the same way. We want to start by identifying the LCD. So what is our least common denominator? What is in our denominators is x minus 3. All right, so my first fraction will stay the same. It already has the denominator of x minus 3. My second fraction will also stay the same. And my last one, I'm going to start by writing as 9 over 1. And we do need the x minus 3 in here. So I'm going to multiply by x minus 3 to the top and the bottom. Okay, so what do we have here? We have x over x minus 3 equals 3 over x minus 3 minus 9x minus 27 over x minus 3. I'm going to put the 9x minus 27 in parentheses so that I remember to distribute the negative. Now that all of my denominators are the same, I can cancel them. Now I am left with x equals 3. I'm going to go ahead and distribute my negative. I have minus 9x minus negative 27 becomes 27. I can combine my like terms. 3 and 27 combine to give me 30. This is a linear equation, so I'm going to add 9x to both sides and get all of my variables on the left. All of my constants are already on the right. We get 10x equals 30, and then I can divide by 10. We get x equals 3 for our answer. We want to check our solution. So I'm going to plug 3 into my original equation and see if we get 0 in the denominator. If we plug into the first fraction, we get 3 minus 3. Is that equal to 0? And the answer is yes. So this is something new for us. We haven't seen this before. What we have is we call 3 an extraneous solution. And what this means is that we haven't done anything wrong, but it doesn't work in the original equation. So, since we cannot plug this in, what is our solution? There is actually no solution to this equation. All right, we're going to go ahead and backtrack through the notes. We're going to go back to example C. This is a special case. This is actually a proportion. If you recall proportions from pre-algebra, basically proportion is a fancy word for fraction equals fraction. But when we solved proportions, we cross multiplied, and that's what we want to do here. So I'm going to multiply x times x minus 3. And I'm going to multiply 3x minus 10 times 2, or 2 times 3x minus 10. So we have gotten rid of our fractions. We can go ahead and finish solving. So we're going to go ahead and distribute to clear our parentheses. If we do this, we get x squared minus 3x equals 6x minus 20. Another thing that makes this different than the previous examples we've looked at is this is not a linear equation, this is quadratic. So my next step is, remember that for quadratics we want to move everything to one side and we want it equal to 0. If we go ahead and combine our like terms, we get x squared minus 9x plus 20 equals 0. I can go ahead and factor this now. Things that multiply to x squared, we have x and x. Things that multiply to 20 and combine to 9 are 4 and 5. This is a multiplying to a positive 20, tells me same signs. And same signs combined to negative 9 means that they are both negative. We can set each factor equal to 0. And solve. So in my first one, I can add 4 to both sides. We get x equals 4. Second one, I can add 5 to both sides. We get x equals 5. All right, let's go ahead and check our solutions. Let's start with x equals 4. If we plug into the first equation, the bottom, we get 3 times 4 is 12, minus 10 is 2, not 0. We're okay there. And 4 minus 3 is 1, not 0. So we can go ahead and keep x equals 4. Similarly for our 5, 3 times 5 is 15. Minus 10 is 5, which is not 0. 5 minus 3 is 2, which is not 0. And so we can keep our x equals 5. And so this problem has 2 solutions. All right, let's go ahead and look at example E. We have x plus 1 over x equals 5 over 2. So the first thing I want is my LCD. My LCD is going to be 2x. My denominators, I have 2's in my denominators and I have x's in my denominators. So it will be 2x. All right, so in order to get this, the first thing I'm going to do is I'm going to rewrite my first term x as x over 1. How do we get to a denominator of 2x? We're going to multiply top and bottom by 2x. Second fraction, what do we need to do there? We're going to multiply by 2. And the last one, we're going to multiply by x. All right, so what do we get? We get 2x squared over 2x plus 2 over 2x equals 5x over 2x. I can cancel my denominators. And I am left with 2x squared plus 2 equals 5x. This is a quadratic equation, so again, just like on the previous example, I'm going to go ahead and move all of my terms to one side, so I'm going to subtract 5x and put it in the middle. We get 2x squared minus 5x plus 2 equals 0. From here, I want to factor. 2x squared, how does that break down? We're going to get 2x and x. Things that multiply to 2 are 1 and 2. My 2 needs to go in my second set because it cannot go with the x or with the 2x. So we're going to put a 1 in the first set. And we have same signs, both are negative. All right, if we go ahead and set our factors equal to 0, we get 2x minus 1 equals 0, or x minus 2 equals 0. For the first one, I can add 1 to both sides. And I can divide by 2. So we end up with x equals 1/2. For the second one, I can add 2 to both sides. And we get x equals 2. All right, so if we go ahead and check this, remember we just want to know, are the denominators equal to 0? We're just going to be looking at 1 over x, since this is the only one that has an x in the denominator. So 1/2, is it 0? The answer is no. So we can go ahead and keep this solution. All right, what about the other one? 2. If we look at this one, is 2 equal to 0? The answer is no. So we can keep this solution as well. And that takes care of solving rational equations.